In this question, we are asked to calculate the work done in bringing a charge of 3 times 10 raised to the power minus 5 coulomb from a point 50 cm. Suppose another charge of 2 times 10 raised to the power minus 4 coulomb is placed 20 cm to that point along the electric line of force. That's what we're seeing here. What do we do? Very simple. We need to consider the potential difference between X and Y. For us to be able to solve that question, we need to consider the potential difference between X and Y. And to do that, we must take into consideration the potential at Y due to the charge 2 times 10 raised to the power minus 4 coulomb. After which, we now find the potential at X due to the same charge, Q1. By the time we finish resolving this, we now apply work done. Work done, the formula for work done, to evaluate the remaining aspect of the question. So let's go. Potential at Y. Potential at Y, that is Vy. Okay? Vy is given as, of course we know that we have 2 times 10 raised to the power minus 4 all over the epsilon naught 4 pi epsilon naught r squared. That should be for Y. If we have this, that's okay. Then potential at X, okay, should be Vx is equal to, what do we have again? The same value, 2 times 10 raised to the power minus 4 all over 4 pi epsilon naught r squared. This one is to be X, this is Y. So with this, we'll be able to find the potential at each point, respectively. So let's go. If we do that, and already we know this, without wasting time, since we have this, we can now see that potential across between X and Y, can be taken as Vxy is equal to, we have 2 times 10 raised to the power minus 4, the same, right? Over epsilon naught 4 pi epsilon naught r x comma y squared. I'm going to explain this further. Okay, I'm going to take time to explain this further. So if we do this, look at what happens here. Vxy is equal to, this is common, 2 times 10 raised to the power minus 4 all over 4 pi epsilon naught. Alright, bracket open because we need to consider this. The radius or the distance separating the two charges Q2 and Q1 is 50 cm. When we are considering the potential at Y, we use the 50 cm. While considering the potential at P, that is between X and P, we use 20 cm. I repeat, the potential between Y and P, we use 50 cm as the distance separating them. The potential at X, we use P, okay, between X and P, we use 20 cm. That's what we're going to do. And quickly, without wasting time, we have that 1 all over for this 50 cm, when converted to meters, becomes 0.5. And this is going to give us 0.5 all squared minus 1 all over. This becomes 0.2 by the time it is converted. All right, and we have that again, all brackets closed. So we have this, and it's very simple. The next thing we need to do, by the time we evaluate and then find that our K is given as 9 times 10 raised to the power 9 Newton meter squared per Coulomb squared. We have this. we substitute for the value of that. That takes the value of 4 pi epsilon naught. And this becomes V xy is equal to, for k, we have 9 times 10 raised to the power minus 9. And then for that charge, we have 2 times 10 raised to the power minus 4, bracket close, and open 1 all over 0.5 minus 1 all over 0.2, or bracket closed. With this, we can now find the value of the potential difference between Q1 and the Q2. Look at it very well. Look at it very, very well. Now, what do we do here? It's a simple thing. What we need to do, let me take chalk. What we need to do is to simplify. And by the time we simplify, we have that potential difference between x and the y is given as, watch this, 54 times 10 raised to the power minus power 5 volts. That's what we're going to get. But if there is any doubt, in the steps I have outlined, quickly put it in the comment section and then we will discuss it. I will address it. I will address it in my next video, right? Okay, so now we have understood this. How do we not find the work done in carrying this or bringing this from so point to whatever point at this point? So what do? We recall that work done is given as W. Look at it. Work done is given as W. Q, that's the charge in question, and then potential difference between X and the Y. If we have this, the charge we are discussing that will be taken from that point is 3 times 10 raised to the power minus 5, and that gives us 3 times 10 minus 5. Then the potential difference we have found is 54 times 10 raised to the power 5. 54 times 10 raised to the power 5. Bracket close. Okay? If that is not clear, let me rewrite that for clarity purpose. So we have our W, that's work done, is equal to the charge given is 3 times 10 minus 5. Alright, brackets. Potential difference we have found between X and Y is given as 54 times 10 raised to the power 5. And then bracket close once again. So what happens here? Very simple. Of course, you know this. It becomes that 3 times 54 times 10 minus 5 plus 5. This goes. And at the end, we have this. We are going to have 162 joules. 162 joules. Solved. So the work done is this. The work done in bringing a charge of 3 times 10 raised to the power minus 5 Coulomb from a point 50 cm. Look at it. From this point X to that point Y, the distance separating them is 50 cm. We need to do some amount of work, bringing this charge Q2 to this point, and that's the work done. That's the amount of work expected to be done in order to be able to bring this to this point. And we have found it. Then the difference, the potential difference between X and the Y, is what we have found here. And it's very simple that way. So with these, questions in this form can be clearly stated and then the answer can be clearly found. That's what we're trying to discuss. So look at it very well. If there is any doubt, as I've always said, put it in the comment section. Don't forget to give me some thumbs up. Push on the bell button for constant notification. And then remember to share to your friends, network, and then students. I am going to sign out now. I thank you so much for your patience and for watching up to this moment. See you in my next class. I'll be linking something up there for you and also somewhere there. Come on, I leave you. Put your question in the comment section. I will address it. Thank you.